If it's okay with everybody, I'm going to record this so that those who can't make it can see it. Howdy. You can turn on your camera so I can see your faces at least, if you've got them. You can even turn on your microphones if you want to. I don't mind.
Hello.
Now we're coming along. We're up to 10 students. Keep going. As I said, I'm recording this. I hope that's okay. At least one student can't make it. He asked me if I could record it or have it again. And I think recording's the easiest way. So I did put the record on. Trying to hide from somebody, you might have to turn off your camera or something. You are now going to be hearing a problem I have all the time. My cat is crying. She's not hungry. She has plenty of food, but she comes in and I think she wants to be a Zoom star. So she keeps coming to the Zoom sessions. Now, look at all the people, Tilly. Okay, maybe that has given her enough chance to go back. Okay, we're doing pretty well, up to about 29, which is good. I'm going to begin in about a minute. It's only 10 o'clock, and I'll give everybody at least another minute to show up. There we are. Okay, I'm going to begin and people can join in. I'm Frank Ford from the Department of Mathematics, Computer Science. I teach the whole range of the computer science. Last semester, I taught 225, which is the next course you're going to have to take after 104. And this semester, I'm teaching networks, which is 433. I've got two sections of 104. I've taught it many times, but I've never taught it to students who have had 103 in Python. So it's going to be a little bit different. I'm assuming that all of you had some kind of a course in Python last semester, presumably 103. You probably had it with John Seifert, and I know that you would have gotten quite a lot of information out of that course. What I'm going to do right now is I'm going to bring up one of the screens I have. So I'm going to try to share a screen, and the one I want to share is this one here. Can you see a screen there?
Yes.
Okay. Now, I'm not going to be in the office, so my office is irrelevant at this point. If you want me, just drop me an email. I'm on the computer just about every night. Occasionally, I have something to do, maybe in the early part of the night, but I almost always can set up some kind of a Zoom session within a few hours if you've got some time. So I enjoy it. It's fun. I don't mind having Zoom sessions. I like them. I like to connect with you. So don't be bashful. If you need any help, please send me an email. There will be tutors. I just got permission to hire 4 tutors. And I've got 4 tutors lined up, but they won't be needed just yet. So I'll let you know when that happens. What they're going to do is set up their own Zoom sessions where they'll be available at certain times during the week, and then you can talk to them. But please don't let the tutors write your programs for you. If you do, you won't learn anything. And that's not what we want. Now, I might tell you that I have become returned to my normal life of being a night person. So don't expect to find me too early in the morning if you're sending me emails. You may see some things arrive at 1 a.m. or 2 a.m. or something like that. Probably I shouldn't tell you that, but that's the way it is. Now, so I go down here. As I said, I'm assuming that you know Python, that you've used it either with the Spyder or Jupyter platforms, probably Spyder, since that's what the college has. You've gone through most of the ways of programming. You may not have spent as much time on classes, but that's okay. We'll pick up there. You haven't done pointers and you haven't done recursion. And those are 2 of the major topics of this particular course. The idea is the most important part to me of computing is the algorithm. You need to be able to know how to solve problems. You need to be able to take a problem and break it into pieces that a computer can do. It doesn't matter deep down which language you use. The same algorithm can be implemented in Python, C++, Java, all the other languages you may have heard of. The real important thing is being able to translate it into something, being able to get an algorithm. So I'm not going to be reteaching how to do the algorithms, although I will probably end up doing that because I know I had to do some of that in 225 last semester. So we'll just, we'll take it, play it by ear, and we'll do the best we can, I hope. Now, how do I grade this course? Well, first of all, I'm going to have lots of homework. Most of them will be small. Give you some idea, I had 26 last semester in 225. Now, some of them were very simple. None of them are huge, I hope. So there won't be as much burden as it may sound right now. Remember, we have a lab assigned to this. So this is just the stuff we would do in the lab. I made it 90%. Now I'm trying something new and I don't know if this will work. I'm going to try to have an extremely short oral exam at the end of the semester. I put away like 3 or 4 days for it. It'll only be about 15, 20 minutes. And all I'm going to do is pick out something from the projects you've done and ask you to sort of explain it to me. That way I can just have some idea that you're going over some of the things. I'm going to try to make them individual, or at least have many different things, parts that I can try, so that they're not all exactly the same. I have 40 something students. I think it's 48 students. So it's probably going to take me about 24 hours to do these. But I fought back and forth over whether I should do it, but I feel kind of like I want to do it. There won't be any written exams. There'll be no final. So I believe Professor Seifert had the same policy. We talked about it. If I remember correctly, he didn't want to have any exams either. Is that right? Did you have him, or did you have
Yeah,
Vonnie?
that's right. We didn't have any exams.
Okay, good. Now, I'm using asynchronous, which means basically I'm going to be making some videos. And every time I make a video and post it, I'll actually be posting it on YouTube, but I'll send you the URL so that you can get to it. I usually also accompany each video with notes, like I'm doing right now. And so I post the notes also on Sakai. If you want a session one-on-one, again, please just ask. If there's something wrong with the notes, or if I put them up wrong, let me know and I'll try to fix it. So that's the way I'm going to do it. I'm not going to say that I'll do every Monday or every Wednesday or whatever. I'll try to do them as I think we need them. So I more or less have one where I have the notes ready. And if I just get some time tomorrow, I'll make a video to start it off. I'm not going to have a book. There's so much on the web that you can find almost anything you want. You can find sources everywhere. And I find most books just don't fit well. They're either too easy or too hard. They don't seem to have the right kind of level. So if you want a book, there are several good ones. We can talk about that. You can call me and we can talk about it. But I think it will be reasonable to look up things on the web as you need to. I always put together a syllabus. I usually end up having some problems keeping exactly to it, but we'll do what we can. As you can see in this syllabus here, I've broken it up into weeks. And what I'm planning to try to do is to do what I would normally have done in a 103 course, if it were in C++, by roughly March 15th. Then we'll start into the pointers, recursion, trees, many other things, including a little bit of an introduction to the kinds of material we will have in 225 next year. That's my plan. Do you have any questions? Anything you want to ask about that before I go on? Everybody clear? Okay. I'm going to stop the share now so I can bring up a different file. The next file I'm going to bring up, and this is also out on the web, is this one here. If you're at the college within the firewall, you can use the C++ Visual Studio that we have on the college machine. However, outside the firewall, there's no way they will, the license doesn't allow us to put it outside the firewall, to have it be used outside there. At least that's the way I understand it. So if you're at home or you can't get to the college site, you're going to need some kind of C++. I use Visual Studio, and you can download Visual Studio for Windows from this source, and for Macs from this source. I only have Windows, so I can't promise you much about the Mac. I did try to set up a virtual machine with the Mac, but I haven't used it much yet. I'm going to try to use it some this semester to get an idea of what some of you might be fighting if you're on the Mac. Both of these are listed as free. There's something called a community edition, and I think it will be sufficient for what we're going to do. So probably your first chore, if you haven't already done it, is to download some C++ if you need it. There are other platforms. Mac, for example, has Xcode, which is not bad. Many people use that last semester. If you prefer Xcode, that's okay. When you send it to me, Xcode has a nasty little habit of not detecting a certain error. The error that your program runs, but when I get it, my compiler, my Visual Studio is fussier, and it says, I'm not going to accept that. So when that happens, I usually ask the student to show me the page where they got the output, and then I accept it. So it's just been a little bit of an annoyance. I don't know why Xcode isn't fussy enough in some sense. Everybody okay on them needing some kind of a platform to do C++? Now, one of the things that you're going to have to see right away is that Python and C++ are not the same. Python is what we call an interpreted language. That is, it doesn't really create a program and put the program in memory and then execute the program. Instead, it goes line by line. You could be executing along the way, and then suddenly there'd be an error at a particular line. That is a reasonable way to do programming, but it's not the way that the bigger problems are done. Most of the big problems are done with programming languages that are compiled. C++ is a compiled language. What that means is that before the program is executed, the platform converts it into a language that's close to what we call machine code. Everything inside the computer is stored as a string of zeros and ones. The only interpretation of it comes from the software, the programs. So if you were to look inside the machine, you'd see all these zeros and ones floating around. What happens is that you write your code in a more user-friendly language, C++, and then that is translated into something that can easily be put into the C++, into the machine language, the zeros and ones. It's not exactly the zeros and ones. It can be seen as a new language, a different language called the machine language or the assembly language. And that is shown in our architecture course, which you probably will be taking in your junior year. Now, what I'm going to do right now is go through a typical C++ session. I'm going to bring up, I have this all written out on a program that, on a file that is already out there. See if I can find it. Yeah, here it is. What I've done is I've gone through, I did it, and every time I had hit something, I copied it over. I'm going to not use that. I'm going to actually do it one by one. So I'm going to have a different screen come up in a minute. What I have to do is I have to bring up my copy of Visual C++ Studio. It's called Visual Studio 2019. And now I can stop this share, and I then will bring up the share screen for the Visual Studio. And unfortunately, I get two of them, which I don't like. I don't know why. So there's the screen. Now, all I did to get that was that I clicked on Visual Studio 2019. I have lots of programs already in there, as you can see. The part that you probably need to really see is over here in the right-hand side. You click and move down, and you need to create a new project. Now, this is called a platform. You had, most of you use Spider on the Anaconda for your Python. This is one of it's a similar thing. It's a package that puts together lots of things to make it easier for you to do C++. So you create a new project and you have to choose among these. We're always going to choose the console application. That's the way we work at it. From the console, once you choose that, clicking on it, you're going to hit next. And now it says, what name do you want to give to this particular program? You're going to type something in here. So I'm going to do like sample 2, because I already have a sample. This is just like Python. When you save your files, you had to give it a name. And it's similar. The names should be something that's reasonable that you can remember. And once you hit sample 2, you hit enter. And now you can wait just a second and the machine will set up for you. Screen sharing is stopped. This is shared window is closed. So now I got to bring up the what I got when I did that. So here we are. Share this. This was the result. Each of these items here is called a window. There are 4 windows in here. Across the top, you have a set of menus. Each one of these opens up into a set of possible instructions, directions, what you want to do. This upper right, left-hand window is where you actually write your C++ code. The output, the error list comes in. If you get an error, it comes down here. And later you'll see there's an output window that comes up when we have output. These 2 windows over here, we don't have to think about very much at the moment. What we're concentrating on is this coding window here and the possible errors that we see here. Any questions on so far on this? Now, C++ is a language that is different from Python, and that it has more sort of syntax to it. Every C++ language starts out looking like this. The name of the program that we're writing is always called main. Now, that's actually not true. The name is sample 2. But within that, there is always a main routine. It always has the name main, because when the computer begins to execute, it looks for the main program to begin its execution. And we don't use indentation. We don't use colon and then indent. Instead, our blocks are signified by braces, or curlicue braces. There's an opening and a closing. One of the maddening things about C is when you have a lot of these, try to figure out which one you're closing. I don't want to tell you how much time I've spent on that sometimes. Within here, within the braces, you actually write the program, you write the code. Now, the computer always starts us off with something called hello world, no matter what we do. And it also has a whole set of horrible things down here, which I guess you could use, but I don't want them. What I'm going to do, before I do that, Notice the slash slash. What do you think that is? What do you think that compares to in Python?
Commenting.
What?
Commenting.
Yep, perfect. There's another way to do it also, but if you see the slash slash, it means everything from there to the end of that line is a comment. It is for you. It's not part of the code. I'm going to erase all these comments at the bottom by writing them out and hitting delete. Now, if I write, this program is there. This program is complete. Notice this line. This line is similar to something that you are used to in Python. Can you think of what might be like that in Python? All right. Do you remember a line in Python called import? Did you have that? And import brought in certain functions and things that you wouldn't have otherwise. That's exactly what this is. IOStream is a package. It allows us to do input and output to this screen. And the way we get to it is we say # include IOStream, and the brackets are necessary. Now, actually, this machine does it a little, hasn't really put everything I would like in here. Usually, in the beginning at least, I follow this with the line called using namespace std semicolon. What that says is, oh, I spelled it wrong. That's why you notice how it tells me I'm wrong by underlining things. That's part of it. It's holding your hand. What this says is go into the libraries of things that we have, all the different possible functions we can have. And in there, there's a group that are under a space called standard, STD. Those are the place, that's the place you should look for IOStream. It brings up a huge number of things. And many people think we shouldn't use this, but I'm going to use it at the moment because it'll be easier, because what it will mean is I don't have to have that STD : Otherwise, I'd have to have it before every input output. There's one other thing I don't like that the machine has done. It really should have a return 0. Now, what that means, what this is this program is actually being run by the system, by whatever you want to call it, the operating system, whatever. And it's a function to the operating system. The function just thinks of it, the operating system just thinks of it as a function. That function is going to return a value. And if the value is 0, that means to the system, everything went well. So usually we put a return 0 at the end of all functions that have a particular form. There's something else that you probably haven't noticed. By the way, this is all on a handout. I'm going to go over it again in my first video, but I just want to get you the feel for how you use this. There's something you may not have noticed. This little word here, int. There's nothing like this in Python. Python is an untyped, a loosely typed language. Python does not insist that everything be defined as a particular type before it's used, or you will be yelled at by the compiler. You have to tell the program what you're going to use. That even goes with the functions you're going to use. This function returns an int, an integer. And we'll talk more about that. But just for now, I want to explain to you why that's there. Now, once you do this, you just created your code. We can call it the source file. Now you're going to translate this file into something the computer can use. So you go up here to build and you hit. Now, I often use rebuild instead of build because sometimes build doesn't work and rebuild does. I don't know why. It's just the way it is. So I'm going to click on rebuild. And can you see down here that something's happened in the output area below here? Is that part of what you can see? Yes or no? It says it succeeded, no failure, nothing skipped. That's what you want. Now, that means we can now run the program. You can run it in one of two ways. You can click on debug and hit stop without debugging, or you can take advantage of the control F5 and do it without clicking on that, as long as you're inside there. Before I go on, what has happened at this point is the program has been compiled. That means translated and checked for errors. Syntax errors only, not errors that you botched up the algorithm, only errors that you don't know, you didn't speak the language perfectly. Once we get past that, the system is now has a file it could put into the computer and execute. What it has to do is it has to take the program, the translation, load it into the computer's memory, link the items in IOStream that are necessary, and then execute the program. That is the way things work. But today, most packages hide a lot of it. They just, all you do is say execute, and it executes. I'm going to hit Control F5 and see what happens. Now, I think what will happen is you won't see the output, so I will have to bring it in. Yes, I'm right. My screen sharing has stopped, so now I'm going to have to show you what I got when I did that. So this is the screen I'm going to share. That's what comes in. It's a black box. You may be seeing only the black box. I don't know. Are you seeing these spots here? Yes, good.
I think we just see the black box.
Good. Now you notice what's happened is the words hello world have come out. Notice cout had hello world in quotes. Doesn't that look an awful lot like Python? Python just had print and then a parentheses with the items in there. There's a little quirk. You have no idea why this /n is there and why it doesn't appear here. But you'll find out later that /n means after you print hello world, hit an enter key. So then you go to the next line. But that's coming later when we talk more about the language. So that is a quick view through how you're going to be spending the semester doing C++. Now I'm going to go back here and play with a few other things. But first of all, do you have any problems with what I've said so far? I don't expect you to understand the coding. What I'm concerned with is you understand how to look at the program, how to write it, how to execute it, how to compile it when you have code that you know how to do. Is that okay? I'm going to play a little. What I'm going to do down here is I'm going to add another line up here. I'm going to say int time, comma, speed, comma, distance. Now you'll notice there are semicolons all over the place. You'll get used to this. Lines of code usually need semicolons, but IOStream is not a line of code include. It is a directive to the compiler. Int main does not need it. A brace does not need it. You get used to what does and doesn't need it pretty fast. The machine automatically indents for you. Unlike Python, the indentation means absolutely nothing. It's free form. In Python, you get into trouble if you indent unless you have a reason to. You don't here in C++. What I have just done is something that you're going to get very used to. I have just defined 3 variables. The variables are called time, speed, and distance. They are just like the variables in Python. The difference is in C++, you must announce them first. You must introduce them to the compiler before you can use them. And in introducing them, you have to tell what kind of value you want in those particular variables. That's unfortunate, perhaps, but it goes along with the fact that C++ is a highly typed language. This is a type of the variable. And C++ can't work unless you do that before you use it. Now, all I'm going to do is do a very simple program to compute the distance, given that I have how long I've been moving and what speed I'm moving at. I'm going to assume the time is in minutes and the speed is in, let's say, feet per minute. And distance is going to be what I get. Before I go on, do you understand? Now, I'll put that up here for you. I'm going to show you a new way to do the comment. The slash and then an asterisk. And you notice it already pops up another one. This says that everything between those two is a comment. I don't have to put the slash in every line. So what I'm going to do is my comment's going to say the input is time in minutes and speed in feet per minute. The output is distance traveled. Now, does anybody remember the formula for distance given speed and time? If you go for 2 minutes and you're traveling at 10 feet a minute, how many feet have you traveled?
Is it time times speed?
Got it. So the formula, the computation, shall we say, is distance equals speed times time. Now, if you'll notice, that's not any different than what you're used to. You're not talking about anything unusual here. It's the same as you would do it in Python. I think it's exactly the same thing, actually. So what I'm going to do down here, I'm going to ask the user, I'm going to say to the user, would you give me the speed and time? So I'm going to say, please input. I can do it in either order. I'll say time and speed. And I'll just have an extra space there and say semicolon. Now, here's a big difference between Python and C++. In Python, we could have read and put what we were requesting in quotes in the read. We can't do it here this way. This way, we have to output the request and then input the values. And I'm just going to show you how you would do it. Again, I'm not expecting you to get this perfectly. I just want to give you the feel for it. It would be time and speed. And then I would just say distance equals, it doesn't matter what order I use, times, times speed. And then I'm going to see out. Distance is distance. And then something a little bit strange. I'm going to put something here called ENDL, not 1L. What that says is, after I print the word distance, this line, please give me a new line. So whatever comes after will be on a different line. It says inline. That's how you should read it. I use \n in the other program. They're equivalent. It was easier to use this one here. And I'll just move this over to make it all up pretty. But there's my program. Now, I'm ready to see if I made any mistakes. It turns out you can do a shortcut. If you hit Control F5, it'll do the compilation and the execution attempt all at once. So again, I have to, do you see this black item or not? Yes or no? No. Okay, I thought not. So let me bring that up again. I wish this machine would share a little bit differently, but that's life. All right, now I've got, it put out the words I had there. Normally I would be right there, but I had, I went out, so I didn't stay there. So all I do is say, okay, let's just say I go for 20 minutes and I go at 10 feet per second. Notice the input, I just put spaces between them. I hit enter and it says the distance is 200. That's how you write a program. That's basically what we're going to be doing. The last thing I want to show you before we break is I want to make a mistake and show you what happens. So I'm going to make a normal mistake. I'm going to capitalize time. Now let's see what happens. It might be easier if I do rebuild here rather than do the all of it at once. Rebuild. Here comes an error. It says TIME is an undeclared identifier. If I click on this, it shows you it's at line 15. It even has a little mark here. Now, the problem is that you didn't define capital TIME. As in Python, upper and lowercase are not the same. So what we would have to do is make that correction, and then it would work right. So that's an example of what an error looks like. And those are relatively easy to fix. There are some that are much worse than that. I'm going to stop now the share, and I'm going to ask you, are there any things you want to ask me that I haven't covered, or any problems you have, or any fears, or worries, or anything? There's no reason to be worried. We will get through it. It'll be fine. I hope you'll pick it up, and we'll just see what happens. Are there any questions, any problems, anything you want to ask?
I had a quick question. I know the class is asynchronous, but are we gonna have any more meetings as a group like this?
I will if you want them.
Okay.
If you ask me, I will set up the meetings. Last semester, the students said they didn't want them that way. So it's up to you. I don't care. I can go either way. Just don't ask me to do it at 8 o'clock in the morning.
Me
But,
neither.
but I will, I'm willing to do it. It doesn't bother me at all. In fact, I like it better. But
Me too.
I'm willing to do it that way. If you're willing, I'm willing. But
All
I
right,
did
let's
say
see
it
what
was
I can-
asynchronous, so people might complain. I don't know. We'll see what happens. Okay. Good question, though. I'll try to blend them together that way. Maybe what I'll do is I'll have it for all who want to come, and then I'll post what I did afterwards. That's what I'm going to do today. Is that okay for everybody? Are you worried about anything or concerned or anything like that? Okay. You are on track with 103 and 104 for both the major in computer science and the minor in computer science. Both of those are required for those concentrations and minors. This is traditionally the freshman level, but always we have a lot of sophomores in it, and it's no problem. We figure out how to take care of things easily. These are the first two courses of what's really a 4-semester sequence. 103, 104, and then next year, 225 and 325. By the time you finish 325, you should have a pretty good idea of what's going on in programming. And then you'll just be looking at more specific topics. Are there any questions? Well, if not, I'm going to say good night. I thank you all for showing up, and we'll see what happens. So long now, and have a good rest of the night or semester or whatever. So long.
Thank you.
Thank you.
Thank you.
Thank you, Doctor.
Thank you.
So long now.
Thank you,
Thank
Dr.
you,
Ford.
Professor. I
Have a
hope to
blessed
see you
day.
soon.
You have a question? Go.
Oh, no, I was just saying have a blessed night.
Oh, okay. So long, everybody.